Hello there. Imagine for a moment looking up at the night sky and knowing that somewhere out there, beyond the countless stars, another world exists. A place perhaps much like our Earth, orbiting its own star, bathed in sunlight, oceans glistening, clouds drifting across a clear blue sky. Could such a world truly exist? This question, my friends, is what drives one of humanity's most profound quests, the search for habitable exoplanets. But what exactly are exoplanets? Simply put, an exoplanet is any planet that orbits a star outside our solar system. And as incredible as it sounds, we've discovered thousands of these distant worlds already, thanks to powerful telescopes and relentless curiosity. But here's the big question. Are any of these exoplanets actually habitable? Could life in any form exist out there? To answer that, we first need to understand what makes a planet habitable. Scientists often talk about the Goldilocks zone, named after the fairy tale, where conditions aren't too hot nor too cold, but just right for liquid water to exist. Liquid water, as far as we know, is essential for life as we understand it. So when astronomers peer into the cosmos, they're looking for planets within this perfect distance from their stars. Let's take a journey to one of the most promising exoplanets discovered so far, Kepler 452b. Often referred to as Earth's cousin, this remarkable planet orbits its star in just the right place, where water could indeed flow. Imagine a planet about 1.6 times the size of Earth, orbiting a star similar to our Sun. Kepler 452b's year is a bit longer than ours, lasting about 385 days, giving it seasons similar to those on Earth. Could forests, oceans, or perhaps even civilizations be thriving there right now? The truth is we don't yet know, but the possibilities are breathtaking. And then there's the TRAPPIST-1 system. Imagine 7 Earth-sized planets, all clustered around a tiny, ultra-cool dwarf star. What makes this system special is that 3 of these planets sit comfortably within their star's Goldilocks zone. If you stood on one of these worlds, you'd see neighboring planets clearly in the sky, perhaps even observing weather patterns on nearby worlds. The TRAPPIST-1 system challenges our imagination and expands our understanding of what planetary systems can look like. But finding planets in the right location is just the beginning. We also need to look at their atmospheres. Using instruments like the James Webb Space Telescope, astronomers analyze the atmospheric composition of distant exoplanets, looking for biosignatures, chemical signs of life. Oxygen, methane, carbon dioxide, these gases could hint at biological processes happening beneath the clouds. Imagine detecting the first undeniable sign of life on a distant world. It would forever change our understanding of our place in the cosmos. Now here's an intriguing thought. Habitable doesn't always mean Earth-like. Life might exist in conditions we previously thought impossible. Take the moons in our own solar system, such as Europa and Enceladus. Beneath their icy crusts, vast oceans of liquid water exist, warmed by tidal forces from their parent planets. Could similar moons orbit exoplanets, harboring life beneath their frozen surfaces? The technology required to detect such moons is still emerging, but astronomers are optimistic. Future missions like the Nancy Grace Roman Space Telescope and advanced space observatories will push the limits even further, allowing us to see more clearly, understand deeper, and perhaps, just perhaps, discover that we are not alone. Yet the search is far from straightforward. The distances involved are staggering. Light traveling at 186,282 miles per second still takes years, decades, or even centuries to reach these distant worlds. Each exoplanet discovered is observed through indirect methods, such as the transit method, where astronomers detect tiny dips in starlight as planets pass in front of their stars, or the radial velocity method, where slight wobbles in a star's position reveal a planet's gravitational influence. We also have to consider other critical factors, such as the stability of a planet's orbit, its star's activity level, and even geological processes. Volcanic activity and plate tectonics, which have shaped our own planet, play vital roles in maintaining a stable climate and recycling nutrients essential for life. Could similar processes be occurring on exoplanets, shaping their potential for habitability? Moreover, advances in artificial intelligence and machine learning are increasingly aiding astronomers. Algorithms sift through enormous datasets collected from space telescopes, rapidly identifying potential habitable worlds. This synergy between humans and technology accelerates our exploration, bringing us ever closer to potentially groundbreaking discoveries. But beyond technology and science, this search speaks to something deeper: our fundamental desire to connect, to understand our origins, and to find our place in this vast universe. It is an ancient longing, stretching back to the earliest humans who gazed upward, questioning their role amidst the stars. As we continue this incredible journey, one thing remains clear. Each discovery brings us closer to answering humanity's oldest question: are we alone? With every new exoplanet, every breakthrough in astronomy, we expand our horizons and ignite our imagination. So tonight, look up at the sky, knowing that somewhere out there, hidden among those distant stars, new worlds await, worlds possibly teeming with life, or perhaps awaiting their first visitors. And remember, the search for habitable exoplanets is not just about discovering new planets. It's about discovering ourselves and our shared destiny among the stars.